So similarly, I'm also going to define a savings account. Okay, and what the savings account is going to do is also going to inherit from account, because a savings account at the end of the day is a special type of account. Now the savings account is going to have our deposit fee is included. Okay, and let's have this deposit fee is equal to 2. So $2 deposit fee. And then, so what's the only method we really need to change? It's the way we deposit. So now if we deposit an amount, we just have to return, it's the same idea, we return the account, and then we use the deposit function from there, we pass in self, and then we pass in the amount, and then now, because we're depositing, we're actually going to be taking away the deposit fee, so the subtle difference is that we're going to be subtracting the deposit fee. And again, one big mistake that you might make is you might just refer to as this. You might think that this is a local variable or something. It's not. This is a class attribute. So we need to basically get it from a method. So there are actually two ways to do this. You could do self.deposit fee, but remember, because it's a class attribute, we can also access it from the class. So this is a subtle difference between instance attributes and class attributes. But because this is a class attributes, we can do either. Either is fine. But generally, this one is more preferred in the programming community, so just be aware of that. So that's what one I'm going to do. Alright, so let's check this out. So now I have an account, I have a checking account, and now I'm going to also make a savings account. Alright, and so once I have the savings account, if I check my savings balance, it's initially 0. And now if I do savings.deposit of 100, I'll only actually get $98. So, savings, my bad. Savings.deposit. Your balance is $98 because now I've taken that deposit fee. So here, what we've basically done is we've defined a general account class, and now we've defined specific checking account and savings account. And notice how short these definitions are. This is beautiful because we're using inheritance. We're using this account class as basically a blueprint for every single other account out there. So this is why inheritance is so powerful. We don't have to redefine all of this. It makes it more compact and easier to understand. So, inheritance, at the end of the day, is a very good form of abstraction for classes that are specific cases of a general class. So here we have a class, and the way we do it is we simply have the class name, and then we just put in parentheses what class we want to inherit from. And then we have the body of the class. So some terminology to know that you might come up across when looking at inheritance. The base class is always going to be the class from which attributes are inherited. And by attributes, I mean instance attributes, class attributes, and also methods are also going to be inherited. So then the subclass, at the end of the day, is going to be the class that's a specific case of the base class. So in this example, our base class was the account class because that's what we inherited from. And our subclasses were the checking account and savings account because they were specific cases of the base class, which is the account class. And now, a little rule I want to talk about is that looking up attributes and classes can be a little different because we have inheritance. But basically what we're going to do is if the attribute is in the class, we automatically return the associated value of that attribute. So remember, we checked self.withdrawal fee. If we had a checking account object and we checked, hey, what's self.withdrawal fee, it's going to find the attribute immediately in here. It's going to return that. But if we have something like self.balance, there's no balance within the checking account class, but it's going to first check there anyway because that's where we're referencing it from. But if it's not here, it's going to, hey, but I'm inherited from someone else. Let's see if they have it. So they're going to kind of go on a scavenger hunt and look for this attribute. And then they obviously find it in the account class because we have an instance attribute of balance. And so once we find that, we return that. And if it doesn't find it in the base class, then it's going to throw an error that the attribute was not found. So just be aware of that. All right, the last thing I want to talk about today is basically taking this whole thing and looking at it from a bigger perspective. So with object-oriented programming, we have a lot more freedom in how we define things. With functions, it's a little more cut and dry in how we do things. We need to do one job, and there's really maybe only a few ways to get the function out correctly. But with object-oriented programming, we get a lot more expressive power because now we're basically modeling things that can change over time, and systems that have many different functions and many different, like a car can do many things. So we're constantly adding to it, we're constantly removing features, so making it better, things like that. All object-oriented programming is great for handling all those types of things. And I actually, in my time at Berkeley, I've talked to many people who actually look for software engineers and interviews. One of the number one things they basically very hugely emphasize is that you should have good object-oriented design. So that's something that we're definitely going to talk about, and you should definitely practice with. So one thing about object-oriented design is that you should choose your class attributes and instance attributes very wisely. Class attributes are something that's shared among all members of the class. So like a car has one set number of wheels for every single car out there. So that's a good class attribute. But you don't want to have an instance attribute be a class attribute when it should really be an instance attribute. For example, in the car example, we had the gas as an instance attribute. But if I had it as a class attribute, that would mean every single car out there has one notion of how much gas it has, and that's just really weird. So you want to be very careful with how you define your instance attributes and class attributes, because they have meaning. So, and then another huge thing that I've talked about again and again is never repeat yourself. So this is shown in the inheritance example, where notice that instead of defining a new deposit function, I use the deposit function from the base class to help me out here, and then just modify the parameter. So this is very important. When you've implemented something, you don't want to implement it again. Like, it's okay to be lazy when you're programming. If there's one thing you take away, it's good to be a lazy programmer. And there's actually a reason that there's this famous story out there that Bill Gates asked a group of people, hey, he basically told a group of people, if I had to choose between a very hardworking person and a lazy person, I would choose the lazy person because he's going to find the fastest way to do it. So this is and obviously Bill Gates is a computer scientist, so you can see where he gets that from, because as a computer programmer, you want to be lazy. You want to use existing implementations if they're available, so don't give yourself too much work, basically. And then also, we've also talked a little bit about using the specific object to access attributes. So in this example, you see that I used the object to access the class attribute when I could have used the class. But I use the object because generally that's better. It's more clear, and you just make sure that you get the right exactly what you want. So this is just a general paradigm of how we do this. In general, you always want to use the object over the class. And in some specific cases, we might want to use the class because, hey, in this example, I needed to use the class because I couldn't use the object to get the method. So there are specific cases where you could use the class, but generally, you want to use the specific object to access attributes. And then specific to inheritance is very good for an is-a relationship. It worked so well in this example because checking accounts and saving accounts at the end of the day are a specific type of account. And that's why inheritance worked in this situation. But for example, if I had what does an account have? An account has a balance. So inheritance is not good for this. You don't want to make a class balance that inherits from account, because really the balance should be an attribute of the class account. So whenever you have a has a relationship, you should be defining attributes, because you want to say, hey, an account has an interest rate, it has a balance, so those should be attributes. But a checking account is a savings account, so a checking account should inherit. Sorry, a checking account is an account, so the checking account should inherit from account. And same with savings account. So this is a little bit subtle, but with practice, you'll be able to quickly tell when inheritance is a good thing and when it's not a good thing. So be careful with how you use that. Anyway, so again, just to emphasize, object-oriented programming is super important, and make sure you really understand how this stuff works. So we've talked a lot about this. We've talked about how we can have class attributes, instance attributes, methods, inheritance, representation of classes. These are all topics that you should be very familiar with. And anyway, that's all I have for today. Thanks for watching. I hope this was very interesting. I'll see you next time. Thanks.